Hey all, good morning. I hope you're having a good day so far. Uh, Today we're going to be working on factoring binomials 1A worksheet. You may be wondering why we're going back to factoring, which is a big deal in Algebra 1. Well, in the section we'll be doing after spring break, you'll be expected to factor easily as part of larger problems. And since we didn't spend really any time on factoring in the fall, I thought it would be a good idea to spend these few days we have working from home just reviewing what factoring is. I'm going to start this worksheet, Factoring Binomials 1A, with a review of what the greatest common factor is and how we find it. So the greatest common factor, if you have a binomial like we have here in number 1, greatest common factor would be the largest term I can divide both of these terms by evenly, meaning not leaving a fraction. And for some of you, these are really easy. I bet half of you can tell, oh, the greatest common factor here is 4, because both numbers can be divided by 4, and nothing greater than that. And also there's only one variable here, so we don't need to worry about that. So, but if it's not obvious to you, there's a really easy method to figure it out, and it involves using a factor tree. Now, we haven't used a factor tree in Algebra 2, but it's a middle school skill that you should have, and in Algebra 1 you should have revisited it, so this is how it goes anyway. First things first, if you have a variable in one of your terms, you need to separate the number from the variable, like this, the 8 over here and the x over here. Now I'm going to break the 8 down until it's broken down into just prime factors, meaning the factors are prime numbers. So 8 breaks into 2 and 4. Now 2 is prime, so that stops there. 4 isn't, though. It keeps going into a 2 and a 2. And then now I have 3 2's, and those are all prime numbers, so I'm going to stop there and look back at the x. That x isn't doing anything. It's just going to stay there. Now what about 12? Well, it doesn't have a variable, so you can just start breaking it down right now. You can do 3 times 4. You can do 2 times 6. Now, interesting and important thing about prime factorization, it doesn't matter how you start. The prime factorization is unique, meaning, over here I did 3 times 4, and then this is 2, 2, so the prime factorization of 12 is 2, 2, 3. We normally say it from smallest to largest. If I had started instead of 3, 4 with 6 and 2, once I broke that 6 down to 2 and 3, I would have had the same prime factorization. All right. Now this problem just asked me for the greatest common factor, so let's put it together. This is how we do it. Commonly abbreviated as GCF. And what we do is we're going to look for pairs that are in common. So for example, they both have 1, 2. I'll put a 2 there. And then they both have a second 2. I have another 2. And then I make one more pass to say, is there anything else that matches? Now, some of you may say, oh, the 4's match, but we don't count things that are broken down. We only want to look at the ends of the tree. Sometimes those are called the fruits of the tree. So in terms of what's left over, the only thing that's left over on the first term is a 2 and an x, and the only thing left over in the second term, 12, is a 3. So there isn't anything else common. So then we finally simplify this 2 times 2 as 4. And so what I mean by that is that the greatest common factor is 4. So that's how we find the greatest common factor.